Okay, so today is not going to be a lot of just listening to me talk, but I just want to get you started. So you're going to look at the first thing you need to do, which is y is equal to absolute value of x plus 2. And you're going to type it in here. They do have absolute value down here on the keyboard, right here. But you can also just you can just type it. Where is that one? Above the enter key, the key above it, if you did shift, you would get it as well. So the x goes there, and then the plus 2. Javier, pay attention here. Ready? One thing that might help you, because we have to get this onto the grid on your paper, see how my axes are counting by 2s right now? That makes it a little bit more difficult to get it onto my paper. So try going up here to graph settings. You see that wrench right up there? Click on graph settings. I said bless you for your pen falling. That's funny. And not the label. Change the step to 1. If you change the step to 1 on both the x-axis and on the y-axis, now it's counting by 1s instead of counting by 2s, and it's just a little bit easier to see. I'm going to show you that one more time. Okay. Go up here to graph settings, and then change the step to 1 here and here, and it's easier to see. And then, again, you can use a pencil, or you can choose to use a different color for each one. Either way is fine. But you're going to get this onto your paper. So this is called the vertex, the bottom of the absolute value graph. The vertex is at 0, 2. So I'm going to start by graphing that one at 0, 2. And then you need to have at least 1 point on each side as well. And they have to be exact. You can't just draw a random V shape. So going back here, I can see that there's a point right here at 1, 3. That point right there at 1, 3, I'm going to draw that one. And there is a symmetric point on the other side as well. Now you can draw more points if you like to make sure it's perfect, but as long as you have your vertex graphed and at least 1 on each side, you're fine. Okay, and then it says describe the transformation from the parent function. So if I started on the black V and I moved to my blue V, which direction did I move? Up. Anne says up. Anybody want to agree with up or suggest something different? From the black V to the blue V, I moved which direction? Up. I moved up. And how many did I move up, folks? 2. So I'm going to write shift up 2. Okay, and then I'm going to choose a different color. Let's see what I have. I've got red. Okay, I'm going to choose a different color for the next one, and then I'm going to put this one into Desmos too. So I'm going to do that, but you work at your own pace and do yours right now. Okay, so when I do that one, I got my vertex at 0, -3. I'm going to graph that. And then going back to Desmos, I can see I have a point right here at 1, -2. I'm going to graph that. And then the symmetric point on the other side. Alright, so I want you to try to do this graph and the one below it. And then we'll talk about the ones at the bottom. Okay, so transformations to the x value. So notice if it's inside of the absolute value and it happens to the x, it's going to happen backwards of what you think. The general transformation equation accounts for that by using an x minus h instead of an x plus h. So this general function is a little bit difficult to understand. It's kind of abstract. but it will be important to make that connection later on. So when you see y is equal to the absolute value of x plus 1, what it really means is y equals the absolute value of x minus -1. All right, because the equation itself has a minus in it, and so that minus and that minus cancel out to make that plus. And this is why we go left 1 instead of right 1. And if you see y equals x minus 4, the minus is actually part of the equation, so it's minus a positive 4. So here is the general transformation equation. It's going to be y equals a absolute value x minus h plus k. So that minus is part of the equation, and it doesn't mean to move left. All right, so this function, we're not telling you what algebra creates it. We're just naming it f of x. And what we want to do is we want to subtract 5 from the f of x. Notice the minus 5 is outside of the parentheses. If it's outside of the parentheses, is it going to be moving it up, down, or left, right? Look at your first page. I have a suggestion of up, down. Anybody want to join in on up, down? Yeah? Yeah. Because it's outside of the parentheses, it's going to be up, down, and specifically it's going to be down. Okay? So we are going to shift down 5. Now, it is impossible to shift every single point because there's an infinite number of points on there, but we're going to shift the corner points and then just connect the dots. So notice the corner points. Here's one. Here's one. We call these corner points critical points. Okay? You see all my corner points? What I'm going to do is I'm going to count down 5 from each of them, and then I'm going to connect the dots to make the same shape. Okay, and then just use your ruler to make the same shape. Okay. I see some of you need a minute, take a minute, and then we'll talk about the next one and I'll let you figure out how to graph it. So we're going to shift up 2, but inside the parentheses is an x minus 3. So look back at your previous page. Inside the parentheses, you had a minus here with the x minus 4. That shifted which direction? Right. To the right. Remember we were surprised by that? So that minus is actually going to shift us to the right. So shift up 2 and shift right. How many? Are we looking at the same thing? Oh, it was on the previous page it was 4. This one is what?
3.
Okay. Up 2, right 3. Now, each point has to do both those things. So don't stop after shifting up 2 and make a point. Don't do that. You got to do both those directions and then make a point. I'll show you this one. This one right here, I go up 2 and then I go right 3 and I make a new point. Okay? From that point up 2 and right 3, then you do the others as well. Up 2 and right 3. And when you do it, you'll notice that the shape of the graph is the same. It's just been moved up and to the right. So I want you to go ahead and continue working through this packet. I will stop every once in a while and go over some things with you, but I want you to try these things on your own now. So let me unfreeze this. There you go. I can make it a little bit bigger. We're going to check the bottom of page 2. So looking at the bottom of page 2, we said that the first one was a vertical stretch of 3 because it made it taller. And then the second one is a vertical compression of 1/2 because it gets pushed down, it gets compressed to be half as tall. Make sure you have that correct, and then I'm going to talk to you about that next part, because that next part, it gets tricky when you can't put it into Desmos. I get that. Okay. So, in this one, we have a vertical stretch of 2 and a horizontal shift right 1. You will not be able to just copy mine, it's too difficult, so let me explain to you how to do that. You can take your corner point and you shift it right 1. Then you look and see what is the y value of that point. How high is it? It's at 0 right now, the y value is 0, so if I multiply 0 by 2, I get what? Still 0. So this one did not move up or down. All right, and think about it. If I stretch it in both directions, the middle stays in the middle. It's everything else that moves. So that one moved right 1, didn't go up or down. But let's look at this point right here. See that point? So I have to shift it right 1, and then it has to go twice as high. Right now, it's at 0, 5. I'm going to move it right 1, and then what's twice as high as 5? 10. So it goes up here, moved right 1, and then it went up to a y value of 10. So that's what you do with each point. This one also has to move right 1 and go twice as high. When you get down here, I move it right 1, and the y value is -2. What's 2 times -2? It's -4, so that's why it moves all the way down here. And then this last one, it only moves right 1 because the y value is 0 again. Okay? Make sure you have all of those, and then I want you to continue working on the ones that you put into Desmos.
How would you say it basically flipped?
So a lot of people use the word flip. I'm going to give you a math word too.
Okay.
All right, so for number 7, you had a vertical reflection or a reflection over the x-axis. People call it both things. And here's number 9. So in number 9, when you do the square root of a -x, it's going to show you that it reflects over the y-axis. So it reflects horizontally. Make sure you have that, and then we're going to work together on number 7. All right, so we're doing number 8. Raise your hand if you can name one of the transformations on this function. I don't want them all, I just want one. Raise your hand if you can name one. Oh, I know there should be more hands. I see one hand already. 2 hands. 3 hands. All right, Elle, can you name one of the transformations? A shift, what kind of shift do you think? To the right? With a plus? The plus goes to the left. Good. So it's going to shift left 3. And Andrew, what's another one? Good. So this -5 will shift us down 5. Please make sure that you guys get that if you didn't already. And do you know the last one? Yes, so the minus in front, that negative, is the vertical reflection. So we have a lot of transformations to do, and the order does matter. And transformations on the y are done with order of operations. So the negative is applied first, and then the -5. So it says you should apply the negative first. It's actually telling you to sketch it first, but you don't actually need to do that. You just need to be really careful. You can if you want. All right, so let's do it together, okay? All right. So when I reflect a point that is on the line of reflection, it doesn't actually move. All right, this line, I'm reflecting over the x-axis and it's on the x-axis, so the reflection doesn't move this one. And then I can shift it left 3 and down 5. Okay, so that first point, the reflection didn't move it because it was on the x-axis, and then I shifted it left 3 and down 5. Next point is here, right here. I do reflect it first. So right now it's 5 above. I'm going to move to 5 below the line. Okay, that's just the reflection. Now I shift it left 3 and down 5. Raise your hand if you want me to do that one again. Okay. All right, I'm going to do it again. So this is the point. I'm going to reflect it first. Reflecting it over the x-axis brings it from 5 above to 5 below. So I'm here at 5 below. And then I go left 3. And then I go down 5. Now you don't have to wait for me to do each point. You can do these points on your own if you're getting it. Okay? I'm going to do the next one. So the next one's right here. It's 5 above, so when I reflect it, it will be 5 below. It's 5 below. I go left 3. I think actually it should be here. That's left 3. And then down 5. All right, next one is here. When I reflect it, it goes above the line. So it was 2 below, it's going to go to 2 above. And now I go down 5, so it goes below again. 1, 2, 3, 4, 5 down, and 3 left. Do you want to see that one again? You got it? Okay. First it went above because it was reflected, and then I counted down 5 and left 3. All right, the last one is on the line, so when you reflect it, nothing happens. And then you go down 5, 2, 3, 4, 5. Oops, I lost count. 1, 2, 3, 4, 5. And left 1, 2, 3. Now when you connect it, it should look like the same shape that was shifted and then flipped upside down. If it looks different, then something happened. And it happens sometimes. It's really confusing to try to do 3 transformations. Okay. All right. What questions do you have?